All right, so let's see what we can actually use dividing polynomials for. So not pretend, but guess, we have this polynomial, p of x, okay, and it's graphed on the coordinate plane you see right here. I want to sit down and start with what we think are all of the possible factors of the polynomial. So, for instance, we know that we could have x plus or minus something as a factor because we have x to the fourth as our leading term. So x minus 5. Could that be a possible factor? In other words, if you have the polynomial that we see here, is there any way that you could use x minus 5 as a factor? And the hint is, look at the constant term in the polynomial. So if my constant term is 6, is this going to be a possible factor? And the answer is no, because our possible factors have to all be factors of this term here and have to be factors of this term here. So possible factors could be something like x plus or minus 2, x plus or minus 3, x plus or minus 6, and x plus or minus 1. Essentially what we're doing is we're listing all of the factors of 6, and we're saying, hey, those are going to be our possible factors of our polynomial. Now, these are just possibilities. It's not going to be true that all of them will work. So we're going to look at our graph and we're going to say, all right, what are our best possibilities? Okay, so looking at this graph, it looks like, if we kind of zoom in here, take a closer look at this graph, we can see that there are roots, right here, right here, right here, and right here. Now, I think we can all probably agree this is not going to be an integer value. And these ones are questionable, but this one for sure is not. Maybe this one is. We'll have to kind of check, and we're going to see through this process. And maybe this one is an integer value. So it kind of looks like the best possibilities are going to be -1 and +2. So knowing that, we can now come back up to our list of possible factors and we can rule some out. We can rule out this, we can rule out this, and we can say, in order to get a root of +2, our factor would have to be x minus 2. In order to get a root of -1, our factor would have to be x plus 1. So these are our possibilities. Now that we have shortened them, how are we going to figure out which factors really are factors of that polynomial? Now this is where the division of polynomials becomes really important. What we're going to do is we're going to take the x to the fourth minus x cubed minus 5x squared plus 3x plus 6, and we're going to divide it by each of these factors because we want to see, does it go in nicely? Is there a remainder of 0? If there is, then we know that that is a factor of that original polynomial. If we get anything else that has a remainder, then that factor that we're trying doesn't actually work as a factor of that larger polynomial. So I want you to pause the video here, and I want you to take that polynomial p of x, and I want you to divide it by just x minus 2. So we're just going to try that one first, and then come back and check your answer. Now, I'm not going to spend time talking about how I did this because that's what you can go back and watch the first video if you need help with that. No remainder. So what that tells us is that x minus 2 actually is a factor of the original polynomial. So the next part of this process is to rewrite this for a moment. Okay, so our original problem that we were actually doing was we were taking x to the fourth minus x cubed minus 5x squared plus 3x plus 6, and we were dividing that by x minus 2. And when we did that, we got this new polynomial, x cubed plus x squared minus 3x minus 3. Now here's the deal. If we go back up to what we had listed up above as our possible factors, we tested this and it worked. So now what we know is that x minus 2 is a factor of the original polynomial, but we haven't tested this yet. Now the question becomes, should I go back and should I divide the original polynomial by x plus 1? Or is there a way to take my answer that I just got and test x plus 1 in that, would that work? And the answer is yes. If this is a factor of the original polynomial, it will also be a factor of this answer. The important thing that we have to make sure we're doing is testing prime factors. So take the number 20, for instance. Okay, prime factors of 20 are 2 and 5, and that's really it. Here's what I can tell you. I can tell you if I divide 20 by 5, okay, I'm going to get 10. Now, what I know, getting rid of 5 for a minute, is that if 2 is going to be a factor of 20, it's also going to be a factor of 10. And that's really what we're going to do here. So we're going to take what we call, this is actually, it's called a depressed polynomial, and it's not depressed like sad. It's reduced a little bit, but we call that a depressed polynomial. So now what I'm going to do is I'm going to take that depressed polynomial and I'm going to try to divide it by x plus 1. So once again, I want you to pause your video here, try it and come back, and let's compare. Okay, so here's what we've got. Now, what you found out, hopefully, is that this x plus 1 is also a factor. So I now have two factors from my polynomial that I know are going to work. The one that I did earlier, which was x minus 2, and the one I did just now, which was x plus 1. I want to just write those two down so I don't forget. So what I found is that x plus 2 worked and x plus 1 worked. I think it was x minus 2. So I now know that there are two factors of this polynomial that work. And what's really interesting is that depressed polynomial that I got is now a quadratic. Which, you know what, we know how to handle quadratics. We've been working with them all year. So what I could do at this point is I could actually now find the remaining factors by solving for that quadratic. So I've got two factors right now that work. The last thing I have to test, and this is the same thing that we were talking about before, you know, thinking about the fact that we've taken this original polynomial and we sort of factored out two of the factors. What's left, we want to figure out what those solutions would be and what those factors would be. Now, x squared minus 3 isn't going to factor. So I'm going to show you two things here in just a minute, a factored form of our answer and then all of our roots listed out. So let's go ahead and figure out if we were to solve this for x, we would have to add 3 to both sides. Now there's a ton of ways we can solve a quadratic, right? I mean, we can factor, we can use the quadratic formula, we can do what I'm doing right here. And then what I get is x is equal to positive or negative square root of 3. So here's what I have. I actually have two things that I can write here. I can write down what the factored form of this polynomial is. And the factored form of this polynomial would be writing out what all of the prime factors are as a product. So that would be the 2 that we used and we did our division. And then the x squared minus 3, since I can't factor it any further, that's the factored form. Now the second thing that I can take from all of this is what the roots or x-intercepts are, depending on how you like to think about it. And that would be if I took each of my factors and solved them by setting them equal to 0 and solving for x. So my roots are going to be positive 2, negative 1, and then positive or negative square root of 3. There are 4 roots because our highest power was 4. Our factored form, if we were to multiply it all out, our highest power would be 4. If you look back at the graph, both ends were pointing up because it's an even degreed polynomial with a positive leading coefficient. So we're sort of putting all of the pieces together here. Here's what I would like you to do. I'm going to have you guys try just a couple of these, and that's your assignment for this week, for this part of the lesson. You can pick any of the two that you want, and this process is going to be a few steps, and I'll write those steps out for you. So really quick summary of what we did. Take your polynomial, whichever one you choose, use Desmos or your calculator to graph. Look at the graph and list all of the nice factors or roots, those ones that are integer values. Then divide the polynomial by one of the nice factors or roots. Now, I guess it could be fraction that's a nice fraction, like 1/2 or 1/4 or something of that nature. 1/3, some fraction that you can figure out really nicely. You could also use that as a factor or a root. Divide that polynomial by one of your nice factors, and then take your depressed polynomial from the previous step and divide by another nice factor if you can. And repeat that until you get your depressed polynomial down to a highest power of 2. Once you have a highest power of 2, you can solve your quadratic however you want. Factor it, use the quadratic formula, undo the operations, whatever it is that you would like to do there. Okay, so pick any two of these, and I'll have a way for you to submit your work on Classroom.